So good day, and my name is Paul Antonio Novate, and I am here to present my presentation board for our finals project for our Digital Electronics 2 subject in Engineer Lagos. So we were tasked to upgrade our robot and to attach sensors to it in order to solve problems. So I'm here to present my robot, which is named HARP. So it is an acronym for Hospital Assistance Robot with a Purpose. So first, I'm going to introduce the problem statement. So I have here the headlines. It goes this way: burned out. Philippine nurses battle COVID-19 and resignations. So we can clearly say that not on, our health workers are not only battling the pandemic, right, the virus, but also their physical state. They're being burned out. So thus resorting into resignations, which has become a problem, especially in the past few years, wherein there is a surge and it really affects the people because who will serve us if the frontliners are not even there because of the maltreatment of the Philippine government towards our healthcare system. So another headline goes this way: COVID-19, the need to heed stress calls for healthcare workers. So in this article, it's being shown that it's not only the health of those health workers are being at risk, also their emotional state, their mental being, if they were able to see their loved ones. So it has been a toll at the health workers because it has been a very difficult journey having a duty almost maybe 24 hours for some. I mean, the hours are numerous. It's not a very little number. So it has been not only the health is at risk, but also the mental state. So another article: burnout among healthcare workers in the COVID-19 era. So it's here. It's in a worldwide scope. Not only the Philippines experiencing the burnout, but also the other nations. So what can I say? Formulate a problem statement about this. So the COVID-19 has been a burden not only to the regular citizens but also to the frontliners because it has been very difficult for them. The long drought duties, the exposures, the mental instability for, I mean, if they get anxiety whatsoever. So I'm here to introduce my robot, which is designed to assist these healthcare workers, even if just a minute task. So I'm going to connect my problem statement to the SDG I have here, UN SDG number 3, which states that good health and well-being. So my robot, HARP, ensures good health and well-being to hospital staff due to the fact that it lessens the burden from their nature of work. So HARP could lessen their workload, thus relieving additional stress and fatigue when the staffs are on duty. So as the presentation goes on, I will show the features on why I said that HARP could be a great assistance to the health workers. Also, UN SDG number 9. HARP is a product of innovation, thus it will be the source for ideas for other people and also promote the needs to innovate in order to solve crises and real-world problems. So that's my problem statement in my UN SDG. So next we go to the background of the project. So what I am trying to create here, what the impact is my robot gonna do. So I'm gonna explain it here in this portion. So the existence of HARP provides assistance to our frontliners in the hospitals. Its features will be discussed shortly, but basically it aims to assist the task of nurses, such as check patients in the room if they're in or out for security purposes, deliver medicines, and whatever else. So the robot could be of great aid whenever let's not hope, but when if it is inevitable. So if another surge, then maybe HARP could be the leading robot frontliner. Who knows if this gets improved. So moving on, I have here the proposed design. I have here listed at the right hand side of your screen. the materials. So I'm gonna hover my cursor. First, we have the Arduino Uno, followed by the board, which will where will the connectors be attached. Next is the ultrasound sensor, servo motor, IR module or infrared, Bluetooth module, motor, the wheels, the acrylic board wherein it is the base of the robot, and the USB cable in order to attach the Arduino to the power supply. So moving on the next page of my presentation board, the proposed design here is a sample schematic. So I'm gonna zoom in. Sorry about that. Here's a sample schematic of what my robot looks like. So I have here two sensors, the ultrasonic sensor and the IR sensor. Each of these has a function later. So followed by the motor, the power supply, and the servo. So I have here the actual problem, what my robot looks like. So I have here the front view. Here in this cursor, selected with this cursor, the front view of my robot, the rear view or the side view, and of course the top view. So next is that I will go to the features in order to discuss what does HARP do in order to aid our frontliners. So first, HARP can check the patient's room if it is occupied using IR sensor. So here, what I am trying to say is that HARP could enforce security here in the hospital. Like he can check if the room is occupied or not, if the patient has run. So maybe HARP can send an alarm so that it can alert officials that the patient is missing. So it is many uses. So basically, I tried to generalize it that this robot could check the room if it's empty or not using the IR sensor. So more of that will be explained in the testing. So that is for its first feature. Next is the obstacle avoidance, a feature which will HARP use in order to move around the hospital using the ultrasonic sensor. So the ultrasonic sensor attached a while ago here will serve as HARP's mechanism to avoid obstacle in order to move around the hospital. As you can see, the hospitals are full of narrow corridors, full of staircase, full of curves. So this obstacle avoidance mechanism could be a great help to our robot in order to fulfill its functions. Next is the automated control using mobile app. So not only that, HARP could lessen the burden of our frontliners, but also ease their work because HARP can be controlled using mobile app. So the nurse could, the health worker could just sit around and have a coffee break while controlling the HARP, and the HARP will just do the tasks needed. So I have the illustrations. So next, I will go to the results and testing. So I will show the clips of how I test the features of my robot. So let's proceed to that part. For the IR sensor test, I have here two IR sensors, the left and the right. So the value displayed on the monitor, referred to the monitor, will be 1 if no obstacle is detected. That is the analog signal being sent. So when an obstacle is detected by the infrared sensor, the LED here at the sensor will light and the monitor value, referred to the monitor, will be 0. Same goes to the left. So when we put an obstacle at the right IR sensor, as you can see, refer to the monitor, the right value, right IR value will be 1 and the left will be 0 since no obstacle is detected. Meanwhile, if I put the obstacle at the left IR, the left LED will light. Now refer to the monitor, the left IR value will be 1 and the right will be 0. If both of them have an obstacle in front of them, both IR value will be 0. Both will be displayed with the monitor will be 0. Stop. And I can go. So this is the app that we're going to use. So first, I will connect the app to the Bluetooth module by pressing this button. Select the Bluetooth module and then connecting. Now it is successfully connected to the robot. So I will control my robot using this remote control app. So it moves forward. You can see moving in any direction. Rotate clockwise and counterclockwise, backward, forward. So now for the results and testing, I have here shown you the clips that consist of my testing for my robot. So the first shown was the what you call this, the IR sensor, wherein this is HARP's mechanism in order to determine if the room is empty or not. So this could be upgraded because it has so many uses. The obstacle avoidance by the IR is so uh, what you call functional that it could be used to many functions. So I only chose that specific type of function because HARP is being deployed in a hospital. So I think that was the optional choice because there are times, patients come in, come out, so it may pose a security threat. So this is where HARP's IR sensor comes handy because it enforces security for the hospital, even if the staff are, let's say, undermanned or maybe sleepy or whatever else. So next is the obstacle avoidance. So this is HARP's mechanism to roam around the hospital in order to deliver the functions, its functions, so that he may be able to aid the frontliners. So lastly, we have here the automated control using the app. So with this, the uh, person using HARP will have a lesser what you call this, physical exert of effort because HARP could be remotely controlled using the app. So it uh, it is a great what you call this, aid because you don't need to exert that much effort in order to maybe just check a patient or just deliver medicine. So this is where the app comes handy, and this is how it will help the frontliners. So moving on to our learning experiences. So this project was fun to make because we were given the freedom to choose whatever sensors we would like to use for our robot. So my inspiration for this project is my mother, since she is also a frontliner, currently a medical technologist, and I could see her struggles every day. Also burned out, also tired, and just want to rest. Since she's a frontliner, she has no choice but to go into duty in order to serve those who are needed and those who are sick. So I tried to create a robot to be a great aid to those in the health industry, since they are the heroes of this COVID-19 battle that is going on as of this date. So once again, that is the end of my presentation. Once again, I'm Paul Anthony Navate. Thank you for listening.